Hi, all. We are going to walk through the spreadsheet that helps us find an elastic energy. So, we just walked through the lab and collected data to help us find the relationship between elastic energy and length that our elastic cord stretched. So, now we need to plug that data into our spreadsheet because we didn't actually measure elastic energy. We measured the mass of each object, and we also measured the distance that the elastic cord stretched. So we need to work with these numbers a little bit in order to find what we actually want. So if you look down here, this is our spreadsheet. We have a little system analysis, mini system analysis for this lab to help us understand what actually is happening. And we have our energy bars here, and then we have a couple of equations here as well. So what we see from the energy bars is all the energy at the beginning of this experiment. 100% of the energy is gravitational energy. So these two things are equal. Gravitational energy at the start is equal to total energy at the start. So that's going to be pretty important for us. We also have up here the equation for gravitational energy. Whoop, right there. So gravitational energy is mass times the strength of gravity on Earth, which is 9.8 meters per second, always and forever, and the height. At the end down here, we see that the total energy is not just gravitational energy anymore. The total energy is actually the gravitational energy that is still there, as well as the elastic energy that is now stored in our stretched spring. So here we have total energy equal to the gravitational energy at the end, as well as the elastic energy. And then we can actually solve for elastic energy by subtracting gravitational energy off both sides. So that's what we get here. Elastic energy is the total energy minus gravitational energy at the end equals elastic energy. Now, remember, total energy at the beginning was equal to gravitational energy at the beginning. So that's why you don't see total energy in this equation right here. They have substituted total energy out and put in gravitational energy. So that's what we see. Gravitational energy at the beginning minus gravitational energy at the end, and that is equal to our elastic energy. So that's an equation we are also going to need. Okay, so let's clear this and scroll down and look at what we have in terms of our data. So down here, you'll see this is what we have for our spreadsheet, and we have a lot of this information. We have the masses that we used. Now I'm going to plug in the masses that I used in that video. So that was 20 grams, 50 grams, 100 grams, 200 grams, and 500 grams. Now I'm not sure I'm going to need all of them, but since we measured all of them, I'm just going to put them in. Okay. We also measured starting height. So the starting height, the mass, the place we dropped our mass from was always 1.6 meters high off the floor. So I'm going to type in 1.6 to all of these. Now, here's a trick on Google Sheets. You can either type them all in, or if you click in the box, you see this little blue box in the corner, you can click and drag that all the way down, and it just fills it in for you. So pause this video if you need to here to fill in all these boxes with 1.6. Here we're going to put our ending height. So our masses all dropped. So they were all a little bit lower from the floor. Their ending height should be lower. So again, I'm going to plug in the ending height that I got from that video. So when I drop the 20 gram, oh, this is in kilograms. So we got to move that decimal point. Instead of 20, it's going to be 0.02. We're moving the decimal place 2 over. 0.05, 0.1, 0.2, 0.5. So glad I saw that. Pause the video here if you need to and fix those masses. I had them typed in grams, but actually in our equation, we're going to want them in kilograms. So we're just dividing it all by 1,000, moving that decimal place over. Okay, now we can type in our ending heights. The 50 gram was 1.54, 100 was 1.50, 200 was 1.08, and 50 was 0.03. Or that was the 500 gram was 3 centimeters off the floor, or 0.03 meters. Okay, so notice that's all the data that I collected from the video, but none of the other boxes filled in, and that's because we need to code those boxes. So let's go ahead and do that. For our gravitational energy at the beginning, again, remember that is our MGH equation. So we're going to take mass times the strength of gravity on Earth times the starting height. Since we want starting gravitational energy, we want starting height. Okay, every code we start with an equal sign. We'll do that here. Now, instead of typing in mass, gravity, and starting height, I'm going to select them. So I want equals mass times strength of gravity, which is 9.8, times my starting height, which was 1.6 meters. Enter. So that gave me a starting height. Now I can type the code in 4 more times, or I can do that little trick again where I click on that first box, go to this little blue box in the lower right-hand corner. I'm going to click, drag, and drop. And what that does, if you look up here in the function box, you'll notice it has selected the mass and height from that row. So A10 is the mass, B10 is the height. We click down and it has selected the mass and height from that row. So it's just a little shortcut to allow you not to type in the code 5 times, but to type it in once and then click and drag it. I'm going to do the same thing over here with ending gravitational energy. I start all codes with an equal sign. So I want mass, I'll select it, times the strength of gravity, 9.8, times, so shift 8 is my times, the ending height. And then when I click enter, it gives me an answer, but it's the same as my first answer. Let me double check. A9, B9, and this one is A9, C9. So it's correct. It's just rounding. I'm going to click that blue box in the lower right-hand corner, drag and drop. And then I have all my ending gravitational energy. If you need to pause this video here in order to fill in those 2 columns, please do that. Okay, so remember what we really want to graph is distance stretched. We don't have distance stretched on here. We have a starting height and an ending height. So we need a code for distance stretched. Now you'll see that the equation is up above here. Distance stretched in blue, starting height minus ending height. So that's what I'm going to code here. We start every code with an equal sign. I go starting height, select, minus ending height, select, enter. And it gives me the distance that it's stretched. I'm going to use that little blue box in the lower right-hand corner. Click, drag, drop, and it subtracts all my distance stretched for me. Pause here if you need a little extra time to get that code in. Okay, so elastic energy is the last thing we have to code. So let's go up here. Remember, we have a formula for elastic energy. It's gravitational energy at the beginning minus gravitational energy at the end. So let's code for that. Every code starts with an equal sign. And then we're going to go starting minus ending. Enter. And then I will select this little blue box in the lower right-hand corner, click, drag, drop, and I have all my values there. So you can see that because this spreadsheet is rounding for me, a lot of these, like starting gravitational energy and ending for that 0.02 kilogram, that 20 gram weight, ends up being the same. They're not actually the same. I'm just not keeping enough decimals in order for us to see the difference. So elastic energy here is 0. Again, that's just a rounding thing. But we have enough values here, 1, 2, 3 values, I think, to see the pattern. So let's go over to the graph and plug these in and see if we can pick up the pattern. All right, so let's go over to our Desmos link, and we're going to put in this data, distance stretched and elastic energy. Now, since elastic energy for my first two is 0, I'm just going to put in the 0.061 and ignore the first one. So let's go over here. Distance stretched, 0.06, elastic energy, 0. All right, then 0.1 and 0.1. My next set is 0.52 and 1. And then I have 1.57 and 7.7. Okay, so I have my data in now. Let's go down and play with our slider and see if we can get one of these to fit. Okay, so the yellow definitely doesn't fit. I'm going to click off of that. The blue is not going through those first 3. But I'm going to have to change my slider. So I need a little bit more range here. I'm going to click on that 2 and make it a 10 just to give myself a little bit more range to play with. So I'll continue moving that slider. Okay, the green definitely seems to be fitting the best. Again, it's not perfect, but it's fitting better than the blue. I can go back and compare. So this blue, the most I can get it to go through is 2, and then the other 2 are beneath it. The green, I can get it to go through 3 at a time, or 2 with 1 above it and 1 below. So let's go with green. That means we have chosen a pattern. Not only have we chosen a pattern, we now have our equation for elastic energy, and we have our C value for our elastic cord that contains 2 cords. So all of this can now be put into your system analysis. And these are the last 2 pieces we need. We needed elastic energy in order to be that last piece to figure out the length of the string we need. So now we have it. We are done. That's a really big step. So you should congratulate yourself. You should feel good about that. Put that in your system analysis, and let's go figure out the length of string we need, code our app, and then we can go bungee jumping.